All right. So we've been talking about the shapes of distributions, whether they are symmetrical, uniform, skewed to the left or skewed to the right, because you're going to see evidence of that skewness in the measures of center. So the first example is we've got a symmetrical distribution, okay? The uniform distribution is also considered symmetrical. It's got this line of symmetry right down the middle, as does the uniform distribution. Um, but anytime you've got a symmetrical distribution, what you'll notice is that the mean, median, and mode will be equal or approximately equal to each other. They'll basically all fall on the line of symmetry. So if in case you don't remember, the mode is the value that occurs with the highest frequency. So when you look at this normal distribution, a 7 occurs with the highest frequency. All the other values, 6 and 8, right, they have a lower frequency. So the mode is 7 in this example here on the left. Now, by contrast, the uniform distribution on the right, it doesn't have a mode, right? It does not have a mode because there is no single value that occurs with the highest frequency. All of them occur with equal frequencies, so they all can't be modes. It is possible to have two modes or three, even three modes, in a distribution, but not where every single value, every single datum, okay, is a mode. Okay, so this uniform distribution doesn't have a mode. I'd say the mode is undefined here. But let's look next at the median. So the median in this case is 7 because half of the data is less than 7 and half is greater than 7. All right, so if we were going to try and draw this, we would say that half of the data is less than 7 and half of the data is more than 7. So the median is 7. And the same is true over here on the right, is that half of the data is less than 7 and half of the data is less than 7. So the median is 7. It's right in the center. And then lastly, we have the mean. The mean is 7 because the average weight of the values is centered at 7. So what we mean by the weight is the actual magnitude that this number means, right? If we had one datum that was a 4 and we had one datum that was a 10, okay, so even though we have maybe a datum of 4 in our left hand and a datum of 10 in our right hand, let me maybe draw this a different way. So we have one datum of 4 in our left hand and we have one datum of 10 in our right hand. Even though we got one in each, there's a difference between a 4 and a 10, right? Because, a 4 has, quote, like a lower weight than a 10. If we thought of this in terms of US dollars, right? $4 is less than 10. That's what we mean by the weight of the values, okay? So even though we have a $4 bill and a $10 bill, the $10 bill is greater, right? But when you take all of these magnitudes, okay, so you take 1 4, 2 5s, 5 6s, 8 7s, 5 8s, 2 9s, and 1 10, and you add all those up, and you divide by the number of datums, then you get an average. You get a mean. Okay, and the mean is right here on the line of symmetry. So long story short here, with distributions that are symmetrical, the measures of center will be equal or approximately equal. Now, I took some time to kind of define each of these because things are going to change now when we have a skewed distribution. Okay, and that's what I'm showing here. So first, let's look at a left skewed distribution. Now, I think it might be helpful to look at a mode first, right? Now, in this case, the mode is 9. Why? Because a 9 has the highest frequency. On the right skewed distribution, a value of 5 has the highest frequency. Sorry, I didn't draw it the way I expected. A 5 has the highest frequency. So here the mode is 9, and here the mode is 5. And you'll notice that because of the way I have it illustrated in this picture, the mean, median, and mode are not equal to each other, right? Not like up above. Here, the mean, the median, and mode were equal or approximately equal. They were all 7 in this case. But now the mode is 9, the median is 8, and the mean is 7.875. The measures of center are spread apart. Well, the mode makes sense, okay, where it is, because the mode is the value or the class with the highest frequency. Here we've got the value or the class with the highest frequency. Now, what about the median? Well, remember the definition of the median is that half of the data is less than a certain value and half is greater. So half of the data would be 1, 4, 1, 5, 2 6s, maybe 4 7s, and maybe some of these 8s. And then the other half of the data are these other 8s, all of these 9s, and a few of these 10s. So the median is 8, right? Because it's the value that splits the number of datums in half being below and half being above. But the median is no longer centered. It's been kind of pulled. The median has been kind of pulled towards the tail, towards the direction the distribution is being skewed. And so the median is impacted by the direction of the skew. Now let's look at the mean. So the mean is pulled over even more, and why is that? Well, the mean, is dependent on the weight of the smaller values or the weight of the values here. But since we've got smaller values of 4 and 5, that is shifting the weighted center towards these smaller values, toward the skew direction. So we went from a situation where the measures of center were all equal, but now the median gets pulled below the mode towards the direction of the skew, and the mean gets pulled even further away from the mode, pulled even further towards the tail of the skew, or in the direction of the skew. And you can imagine that instead of having just a value of 5, 4, 3, imagine if we had a value of 2 or 1 out here. And let's say we had a frequency of 1 at these extreme values. Then this mean would get pulled out even more. Because these low values, these low weights, would end up pulling the mean in that direction, like that. And you see the same effect here with this right skewed distribution, right? So the data, is skewed to the right in the positive direction. Okay, the mode is 5. Now the median is 6 because half of the values are like 6 and below, and the other half are 6 and above, something like that. And the mean is being pulled away from the mode the furthest because what affects the mean is the magnitude of the datums themselves. So these higher numbers of 9 and 10, that is pulling the mean towards higher numbers. And then you can imagine if we had a few classes out here that were maybe around 20 and 21, okay, that would pull the mean even further out towards higher numbers. So when you're dealing with left skewed or right skewed distributions, you should see an effect of that in the measures of center. All right. So in fact, if you calculate the measures of center first, and you notice that the mode is smaller than the median, which in turn is smaller than the mean, if you calculated measures of center and you saw this relationship, that implies that you've got a right skewed distribution. But instead, if you see that the mean is the smallest value and the median is greater and the mode is greater still, what this is telling you is that you have a left skewed distribution. So the way that this can help you is that if you calculate measures of center first, that'll tell you, what your histogram should look like. Or if you make your histogram first, and let's say your histogram looks left skewed, and you calculate the mean, median, and mode second, they should have this relationship. The mean should be your smallest number, the median should be your next smallest number, and the mode should be the largest number that you calculate. So it can be a method of double checking your work, is comparing your calculations of the measure of center with the shape of the distribution. All right, let's go ahead and stop it there. Let me know if you have any questions.